the New Horizons spacecraft that we shot out to Pluto at 15 kilometers per second. It reached Pluto in 2015. The things that were discovered on Pluto there just don't fit the worldview that says that Pluto is 4.6 billion years old. All of the New Horizons scientists all said it looks young. They're all flabbergasted at this evidence for a young Pluto. And they're surprised because it doesn't fit with their worldview. Those things are very hard to explain in the evolutionary notion of how we got our solar system. For us, we react in amazement and awe of God's creation.
We covered a lot here. We talked about the origins of Pluto's discovery. We talked about discoveries about the atmosphere and the geology of Pluto. So, what do you think is the takeaway here for Christians? When the New Horizons spacecraft sent back data about Pluto, scientists were shocked. What they saw seemed to directly contradict all of their theories about where the solar system came from and how old it is, and may have provided proof that Pluto is not actually billions of years old. So, Richard, I know you've been talking about biblical creation and related topics for 30 years now, more than 30 years now. So, I guess kind of the first question is, how do scientists actually go about figuring out how old a planet is?
Well, it all boils down to worldviews, actually. Depending on your worldview, you will try to fit data from whatever, we'll talk about Pluto, but you try to fit all the data into what you believe. And the thing with the past is, like we're talking about the ages. How old is Pluto? How old is the age of the Earth, age of the universe? That sort of subject. You can't measure that directly. I mean, we have microscopes and we have telescopes. We don't have pastoscopes, right? That's not how it works.
Yeah.
And so you have to have a number of assumptions, and those assumptions come from your worldview. If your worldview is not based on the Bible, and there was no creator God, and it's evolutionary over millions of years, then you're going to fit the data, in this case the age of Pluto and everything else, into that worldview. Well, where does it fit? If there was no God, then things would have taken millions of years. The solar system was formed from a spiraling, collapsing dust cloud over millions. This was billions of years ago. It took millions of years to form, and that's your worldview. And so you'll put the age of Pluto into what you believe about the past. I say belief because you can't test the past scientifically. Science has to do with observations, has to do with things that you can observe in the present. You can't technically prove anything that happened yesterday. Proof is just by itself a very slippery animal to get a hold of.
Yeah.
We can say, this strongly supports this particular view, but proof is a little difficult. For us as Christians, we have a different worldview that doesn't include millions of years. We can deduce from our Bibles, it's not that hard to do this actually, that God created recently in 6 Earth rotation days, and there was a global flood on Earth, not on Pluto.
Right.
But and so in that worldview, then Pluto is not millions of years old. It was created by God. And so there's these two, those are very different worldviews. And regarding Pluto, the origin of Pluto, the age of Pluto, the dating scheme is all different. And so it's exciting to me, and we're going to talk about some of this.
Yeah.
The discoveries that were made by the probe that was sent to Pluto, these different worldviews, we can think of, okay, when the data comes in, see, the mark of a false worldview is inconsistency.
Okay.
It's inconsistency. So the data would be inconsistent. If you have the wrong worldview that doesn't align with reality, data, when scientists discover whatever they're discovering, we're going to talk about Pluto again, it's going to be inconsistent with that worldview. Now, it fits in beautifully with the biblical worldview. I've given away the punchline there. Okay.
Sure.
The end. Go home. But no, the data, if it fits in neatly into your worldview, it's an indication that the worldview is correct. Your beliefs about the universe, how it got here, all your life experiences and so on, if they come from a correct worldview, they will be consistent with what the observations from scientists will be consistent with that worldview. They'll fit into it more neatly, more cleanly than they will a false worldview, for example, evolution over millions of years. And that's exactly, Pluto is a great, some of the data coming from Pluto is a great sort of case study for determining which worldview is more close to describing how things really are, describing truth, describing reality.
We'll get back to the conversation in just a second. But first, thanks so much for tuning in. If you haven't already, hit that subscribe button and turn on notifications. It genuinely helps us keep producing the talk show. Now, back to the interview.
I do want to talk about how that's kind of happened over the years, because we've had to revise our understanding of Pluto many, many times since its discovery.
Yes.
And now we're having to do it again post New Horizons.
Yep,
So
yep.
Tell us more about where that started.
Okay, yeah. Initially, it was Percival Lowell. Percival Lowell, the Lowell Observatory is named after him. He was born in the 1800s, died 1916. He was the first person to propose that there's another planet outside of Uranus and Neptune, and he proposed that based on perceived irregularities in the orbits of Uranus and Neptune. And he estimated that there is a planet out there. He estimated that its mass would be something like 6 times that of Earth. So it's a hefty little planet out there.
Yeah.
And he searched for it his entire life. He died in 1916, never found it. Pluto was found in 1930 by Clyde Tombaugh, and he found it. And the first time it was seen by telescopes of that time, 1930. And its size was quickly revised down to about 3/4 that of Earth. So that, okay, new discovery, new technology, whatever, he actually found it. And okay, well, it's not that big, it's smaller. And then as technology over the years has increased, today, and this was even back in 1978, by that time, the size of Pluto had been revised down to 1/500th that of Earth.
Okay, so tiny.
Tiny, a tiny little thing. So here's the $1 million question, and this is an interesting story, I think. At that small mass, there is no way that it could have affected the orbits of Uranus and Neptune. So the question is, how did Lowell initially see this, that there was a planet there?
Yeah.
And then Tombaugh found it. The answer to that nowadays, it's generally understood that the supposed irregularities that Lowell found there were imaginary. There were no irregularities. And Tombaugh, the actual guy who discovered Pluto, looking in the region where Lowell predicted it should be, it was a coincidence. But Pluto was found by coincidence. So interesting story. But because of its mass, it could not possibly have affected the orbits of Uranus and Neptune.
Yeah, I don't know how you did it, but you got the right answer. You found this planet that was out here, even though the observations were wrong. So how does that connect back then to what we're kind of talking about with worldviews and scientific discoveries and fitting them in?
Yeah, we can relate that to the differences in our worldview of the age of the Earth or the age of the universe. The biblical, we would say the biblical age is way, way different than the secular age of millions and billions of years for the universe and Earth and so on. And like, how can those possibly be true? And it's kind of the same thing with the mass of Pluto. It starts out 6 times the size of Earth, 6 times the mass of Earth, and then it's revised down to 1/500th of that. How could scientists for so long be wrong about the mass of Pluto by many orders of magnitude? And it's because if you use the same methods and the same assumptions, the same beliefs behind that stem from a worldview, if you keep using those same assumptions, you keep getting the wrong answers if your worldview is incorrect. If you start with a right worldview, that at least puts you in the right ballpark for potentially getting the right answers. And so, again, the age of the Earth is a similar thing. You have different worldviews that produce very different results for the age of the Earth and the age of the universe. It's kind of like the creation evolution issue in that sense. Okay,
yeah. As our technology gets better, as just our processes get better, we're going to get better data, and we'll discard some things and keep others, because that's how science works.
Right. Yeah, as our technology gets better, we've been able to, over the years, revise the estimates of the mass of Pluto. Now, you can't, to some extent, like Pluto's observable. It's out there. We're not talking about something in the past. So you can, with assumptions and so on, you can get fairly accurate. We believe today we're fairly accurate about the mass of Pluto. One thing that we cannot observe today is the age of Pluto. Because, again, that happened in the past. Science can't speak to events that happened in the past. There's circumstantial evidence, and there's other evidence that you use to try to figure out if this past event happened this way, or if it happened this way, or if it didn't happen at all. And so that's outside of science. And that's really the creation evolution issue as well, right? It deals with things in the past. Creation evolution is, it's not really a battle about the science. Because again, science involves observations. There's not really a battle about the observations because everybody can observe them. What the battle is about in creation evolution is things that can't be observed. We can't observe the past. Did dinosaurs die out 65 million years ago, or 60 million years ago, or 600,000 years ago, or 6,000 years ago? Like that's where the debate happens in the creation evolution, the origins debate. It's about things that we can't observe. The things that we can observe, there's not really a debate. People find a fossil in some rock, and okay, it's a fossil in some rock. Nobody looks at the fossil and says, "Well, that's not a fossil. It's a bicycle."
Yeah, nobody does that.
There's not a debate generally. There is sometimes, but there's not a debate over the observations. And so again, we can observe Pluto today, and with various assumptions, we can calculate its mass. There's still assumptions there, and there might be some debate about when those assumptions are wrong. But we can't observe Pluto's history. We don't know. So we have to reconstruct its history from things that we can only see today. And that's very much what the creation evolution issue is all about.
Okay, so speaking about those observations, back in the day, we had ground-based telescopes with lenses or mirrors, and you would then just take light off the optical spectrum and look for planets, and that's how we did it. Now our technology has progressed a lot further to where we have space telescopes, which is exciting, but there's only so much that we were able to get from Hubble. So then I remember when this happened in 2013, that's when we launched the New Horizons spacecraft. I was in 8th grade, and I was thinking, oh man, it's going to be forever.
It was 2006.
Yeah.
Were you in 8th grade in 2006?
No, that's not right.
Because it took 9.5 years to get there. It got there in 2015. It launched in 2006.
Oh, okay.
So it took,
Wow.
Nearly a decade to get there.
Okay, so even longer.
It's a long ways away.
But I do remember when it happened.
Yeah.
So they sent the spacecraft out.
Yep.
And what happened then?
Yeah, the New Horizons spacecraft. That was an amazing spacecraft. It's about the size of a grand piano, and it's still out there in space, by the way. It hasn't crashed or anything like that. And it was loaded with sensors. All kinds of sensors for sensing all kinds of things. There's optical cameras and then all kinds of other sensors for measuring different things and sampling, that kind of thing. It was of all the spacecrafts that we've sent out from Earth, it left at the highest speed ever.
Okay.
15 kilometers per second in order for its orbit to reach Pluto.
Wow.
So if we think about orbital mechanics a little bit, so rockets, when they go up, initially they launch vertically, of course, but then very shortly after that, they start to go horizontal. Getting into orbit is all about speed. It's about speed. So you launch vertically, you get through the Earth's atmosphere, and then you start going horizontal, and then the rocket burns and burns and burns, goes faster and faster and faster. And you want to get up to a speed where is it centripetal or centrifugal force?
I can't help you here.
I keep getting those two mixed up. Where that force is enough to counteract gravity. And as long as you don't slow down, you can stay in orbit forever if you don't slow down. Now, when the astronauts went to the moon, they started off in Earth orbit. And then in order to get to the moon, they needed to burn the rocket again and go faster to raise their orbit. So you go faster to get into a higher orbit until they got into an orbit so high that their orbit intersected the moon. And so that's how you get to the moon. Mm-hmm. Pluto is way further than the moon. So they need to go to get the New Horizons spacecraft there. They need to go really, really fast. And so Pluto is so far out there. That's why they needed that speed, 15 kilometers per second. That's amazing technology.
Yeah.
But, anyways, so then the spacecraft gets to Pluto there, and it's loaded with sensors, and they start making measurements. So yeah.
Well, and I remember when those pictures came out, and it was incredible to see Pluto's surface finally.
Yes.
As an adult, as a kid, we're never going to know what Pluto looks like, or we don't know what it looks like. And then to get those and to have the geography and even understand, maybe to an extent, the geology of Pluto,
Yep.
it's just a truly amazing thing.
Yes, and one of the things the atmosphere is amazing as well. So the atmosphere of Pluto is nitrogen and methane and carbon dioxide, and there's some hydrocarbons as well. And Pluto's year, its orbit around the sun, is 248 Earth years. So it's way out there. It's a very long year.
Yeah.
And its orbit around the sun is quite stretched. It's less circular than most of the all of the planets have a slightly elliptical orbit. They're not perfect circles, but Pluto's is quite stretched out. It reached its closest point to the sun in 1990, and it's been getting further away in its orbit ever since. And it'll take a long time before it reaches the high point and then it starts coming closer. And it was thought in 1998, there was a revision of a textbook on astronomy, the new solar system. And one of the authors of that textbook, he wrote that, so this was 1998, that this an updated version of this textbook, very famous textbook, came out. And the assumption was that Pluto's atmosphere, it's now moving, it's getting colder, it's moving away from the sun, it's losing so much of its atmosphere, it's so small that it's probably going to be gone in 20 years. Well, then in 2015, 17 years into that prediction, the New Horizons spacecraft arrives at Pluto. What about the atmosphere? It should be nearly gone into this 20-year prediction. We're 17 years in 2015. It's still there. Pluto's atmosphere is losing 500 tons an hour of nitrogen.
That's a lot.
That's a lot. Well, at that rate, it should have lost its atmosphere a long time ago. If it is actually billions of years old, it should have no atmosphere. Now, we've known from Hubble Space Telescope images that Pluto has different shades on it. There's lighter and darker areas of Pluto, and the prediction back in 1998 in this textbook that was written was that in 20 years the atmosphere is going to be gone and it's just going to be white. It's going to be a frozen wasteland. It's all going to be the same color. It's still multicolored today.
Yeah.
And so, and the atmosphere was a huge. Was very, very interesting. And there's other things that it saw as well. Of course, the geology there. There's glaciers. There's geysers. There's mountains of ice that are 11,000 feet tall. And very interestingly, there's large portions of Pluto that have no craters, no impact craters.
So what's the implication there then? That it's new, just because it has no craters?
Well, you've got a number of options there. If there's no craters, that means it could have been recently resurfaced. But for the millions of years, folks, the big surprise is that Pluto looks young. All of the researchers, they didn't expect the atmosphere there. And these geologic, like geysers and glaciers and massive mountains of ice, 11,000 feet tall, and this uncratered surface, it's a new surface. It hasn't been there long enough to get craters. Or that's one option. It hasn't been there long. It's a young surface.
Yeah.
Or there are craters underneath, and it's been recently overlaid by some kind of geologic process that is new again. And there hasn't been enough time there for the impacts to produce craters. One thing that all of the scientists, all of the New Horizons scientists associated with this New Horizons program, they all said it looks young. It looks young. One of the researchers estimated that it looks like it's about 100 million years old. Now,
compare that to like 4.5 billion or something for.
That's 1/45th of the supposed evolutionary age of what the other objects in the solar system are supposed to be, 4.5 billion years old. That's crazy. You know, the things that were discovered on Pluto there just don't fit the worldview that says that Pluto is 4.6 billion years old. The discoveries being made fit neatly into a biblical framework, a biblical worldview, but this notion that it's 4.5 billion years old, it really flies in the face of what scientists are actually observing with this New Horizons spacecraft.
I hope you're enjoying the episode thus far. As you can imagine, episodes like this require a lot of resources, time, and hard work behind the scenes. We're committed to getting this message out and bringing you more of the talk show, but we can't do it alone. Every contribution, big or small, helps us handle production costs and continue making more content. To help chip in, use the link below or the on-screen option. We're grateful to all of the financial supporters that make Creation Ministries International possible.
Okay, so you said this researcher says Pluto can only be 100 million years old, but you and I maintain that the Earth is actually, and the universe and solar system are 6,000 years old.
Right, less than 100 million years. Right, they're trying to push that age as far as they can, and which is crazy, even for one of the scientists to admit that believes that all the other objects in the universe are 4.5 or 4.6 billion years old, somewhere in that range. Then to wind that back to 100 million years, that is a bold statement by some of those scientists. But obviously, if it could be that young, then 6,000 years, if it's around 6,000 years, it also wouldn't be cratered, would it? I mean, the point is, it's less than 100 million years old from their perspective, which to me, that's an amazing statement that they could even publish something like that. These are published statements from the New Horizons scientists that are saying things like this. It's amazing to hear from their own pens and their own lips, essentially, that they're all flabbergasted at this evidence for a young Pluto. And they're surprised because it doesn't fit with their worldview. Fits with ours, so it's fun for us.
Well, and they say that the solar system, it all came about 4.5, 4.6, and I know
around there.
There's margins of error there for those estimates. And that's the evidence is not supporting that that's where Pluto came from.
No,
and
not at all.
I know there's more evidence that you've talked about with Pluto's moon, Charon. I'm not sure if I'm pronouncing the Greek name correctly.
Charon. There's different. Charon, I think, is the most popular. But that's Pluto's largest moon. It's about half the size of Pluto, so it's a pretty big moon. Yeah. And then there's actually 5 moons, and there's smaller moons. So there's Charon, there's Kerberos, there's Hydra, there's Styx and Nix. And so those are the 5 moons.
All like Greek underworld themed names.
Like Saturn and Mars and you have all these Greek gods or whatever.
Or they might be Roman, but it's very
I'm getting my gods mixed up. Okay, so please forgive me. All right, whatever.
So Greco-Roman underworld deities.
Yes.
It's very on theme.
Yeah, and so a lot of moons, like take our own moon, for example, moons are not generally point objects. Right, so there are heavier sections and lighter sections, and over time, as they rotate or as they revolve around their host planets, the heavier end will end up. It's called tidal locking. It'll be tidally locked. The heavier end will always face its host planet, and our moon does that as well. We only see one side of our moon. We don't see the first time that the other side of the moon was seen was on Apollo 8, where the 3 astronauts orbited around the moon. That was Christmas time in 1968, where they read Genesis. Yeah, it was amazing stuff. But we never see the other side except for the astronauts in the spacecraft. So the moons of the smaller moons of Pluto are not tidally locked. This is supposed to happen over a long period of time. Well, they're not tidally locked. And the slowest, they spin incredibly quickly. Not only are they not tidally locked, they spin like crazy. Kerberos has the slowest rotational speed at 5.33 hours.
That's 1 day.
One day is 5.33 hours on Kerberos. You get a cycle of light and dark. It's Hydra. Hydra, 1 day is 26 minutes. It
Wow.
makes one rotation every 26 minutes. It makes 89 revolutions in one orbit around Pluto. And again, the new scientists, the New Horizons scientists, their statements like, we've never seen anything like this anywhere in the universe. This exceeds all post flyby estimates. They have these estimates, these guesses that they're making. What are we going to see when the spacecraft gets there? And they have various assumptions. Well, we expect to see this and this and this. And these scientists are making statements like this. This is completely unexpected. We did not, before the flyby, we weren't expecting anything like this. And then it's Nix. Nix is tilted 132 degrees. Actually, its orbit its axis flips. In 2015, at the time the spacecraft flew by there, it was 132 degrees off axis, and it rotates backwards. It spins backwards. Like those things are very hard to explain in the evolutionary notion of how we got our solar system. The evolutionary notion is the millions of years notion, no God, is that the solar system was produced from a spiraling, collapsing dust cloud, and you have that spinning there, and you have the law of the conservation of angular momentum.
And what's that?
Yeah, and that is that that motion. It's like one of Newton's laws, right? And that motion is going to be preserved. That rotational energy is going to be preserved, so that all the objects in the solar system should be on the same plane, and they should be rotating in the same direction.
So like this is the way that the gas cloud was rotating. This is how it was distributed.
Right.
And all the planets are going to basically keep moving in the same way.
Yeah. So you've got Nix out there that's like this and going backwards. Actually, Venus. The planet Venus actually spins the other way, right? These are, and you need to come up with some very imaginative scenarios to explain those things. For us as Christians, God is a creative genius. To say the very least, that's almost blasphemous. God's creativity is unlimited. And so every planet and every moon that we've sent probes to or looked at with telescopes, most of them are vastly different from each other.
Yeah.
So there's this amazing creativity there. We see that on Earth here. That like how many flowers are there? Like there's blue ones and red ones and green ones and yellow ones and pink ones and red, and the planets are the same way. That generally, it's thought that in the secular way of thinking, the evolutionary scenario for planet generation and so on, it's okay. Planets this far from the sun are generally going to be like this, and planets this far from the sun are generally going to be like this. That's not what we're seeing. There are some generalities there, but then you go to Pluto and you find these moons that are spinning in 26 minutes, and one's tilted on its side and it flips back and forth. And some of the moons also, they're precessing.
Okay.
What that means is, you know the tops?
Like a spinning top.
Yeah. When you first spin a top, it wobbles a little bit, right? That's precessing.
Yeah.
Precessing is wobbling.
Okay.
It wobbles, but then it straightens out after time, and it just sits there and spins. Well, some of the moons of Pluto are still in their wobbling phase. It's like they've just been wound up, and they haven't yet settled down. It's again, these things are a challenge to include in the evolutionary worldview that says these things have been here for billions of years.
Yeah, it seems like this happens every time we send out these new spacecraft to go somewhere. Like,
Yes.
Was it Cassini that landed a probe on Titan? Was it them, or was it a different probe?
I'm not sure the names. I've heard of Cassini.
Yeah, I remember
Was it Jupiter though? Yeah,
It was
okay.
it was doing a flyby. I think it was of Saturn. But anyway, I remember the first time we sent a probe to Titan, and there were so many shocking things that we found. In some ways, it was very familiar. Like somebody said, "Hey, this." When they saw pictures, they said, "Hey, this looks like my backyard in Arizona."
Yeah. Yeah.
And then other things that we find are just amazing. So like, I would love it if we, got to send out a probe to, for example, Europa. I've been waiting on that for forever. Or any of like the Jovian or Saturnian moons. Because there's like dozens and dozens of them. it's just incredible to think of, like, with all the advances that we're having, what we're going to discover next, because we never really know.
Yes. Yeah. And these sorts of things happen all the time. There's all these surprises, right? Like when it was the Galileo spacecraft that went to Io, one of Jupiter's moons. I think that was 89, that it went around Io, mapped the entire surface of Io for the first time, and they discovered 80 active volcanoes on Io. Well, Io should be like Pluto, same thing, and Pluto's moon should be old, cold, and dead.
Yeah.
Old, cold, and dead, right? That's the scenario. Given their distance from the sun and other factors, their gravitational interaction with their host planets and so on. Io also, around Jupiter, should have been old, cold, and dead. 80 active volcanoes. If those volcanoes had been acting at only 10% of their currently observed, so not 80, but 8, if you had 8, given the size of Io and so on, 8 volcanoes over 4.5 billion years, Io would have erupted its own volume more than 40 times. In that doesn't make any sense.
Yeah.
Right? What makes more sense is that Io is not 4.5 or 4.6 billion years old. It's everywhere we go, there's these surprises that come up, right? And we react to the surprises differently between these different worldviews. For the evolutionists, for most of the New Horizons spacecraft scientists the scientists associated with that program are not Bible. They don't have a biblical worldview, and so the surprises that they're finding from the data that's come back from Pluto is, wow, this is really hard. What are we going to? How do we fit this into?
Yeah.
And how do we fit this? For us, it's like, wow, look at the variety that is being discovered here. It causes us to worship our Creator God. The heavens declare the glory of God, right? Yeah. And so everywhere we send probes, it's, yes, we react to those surprises differently. We react in amazement and awe of God's creation. The evolutionists that have, I would say, the wrong worldview, and that's why there's inconsistencies there between what they expect to find and what they do find. They react to the surprises in a very, they have a tough time with them, right? Yeah. To say the least. It's like, well, this doesn't fit with our worldview at all. So now we need to revise the age of Pluto down to less than 100 million years. Okay, how do we do that,
Yeah. So we covered a lot here. We talked about the origins of Pluto's discovery. We talked about the development of the New Horizons program and how that mission went. We've talked about its discoveries about the atmosphere and the geology of Pluto. So what do you think is the takeaway here for Christians?
The takeaway, I think we can go back to where we started from. The mark of a false worldview is inconsistency. There's just one inconsistency after another between what scientists are discovering and the non-biblical worldview, the worldview that has no creator God, no recent creation. It's millions of years of natural processes. The data from the scientific world just doesn't fit with it. It's inconsistent with that worldview. Inconsistency is the mark of a false worldview. And the data fits in very nicely with a Christian worldview. We don't have that conundrum,
right,
as Christians. We don't have that, guess we need to go back to the drawing board here and figure all this, how do we incorporate these data into our worldview? We don't have that problem. And I would challenge our viewers and listeners that if you hold to an evolutionary worldview, a worldview that millions of years old and so on, how long can you keep adding these anomalies into your worldview and trying to make sense of these anomalies in your worldview without questioning whether your worldview itself is false? I would challenge our viewers and listeners to really look, is your worldview really the right direction to go? Because if there's so many inconsistencies, again, it's a mark of a false worldview. Maybe you need to consider the worldview that derives from Scripture, that God created recently in 6 days and there was a global flood, again, on Earth. That worldview provides a much more solid, much more robust foundation for understanding the data that's coming from science. In this case, we've been talking about Pluto, but all the science.
It's everywhere.
It's everywhere, yeah.
It's not getting any easier for people who want to, prove our worldview false. It's not getting any better
it's not.
With the more scientific discoveries that we have.
Yeah, so the ultimate takeaway is that the Bible's true.
Yeah.
That's where I was getting at with this. The worldview that's based on Scripture, we just draw the meaning from the text. That's the one that makes sense of the world around us. And that worldview includes many other things other than science. It includes the notion that all have sinned and fall short of the glory of God. We are sinners. We have rebelled against the Creator God of the universe that has produced this beautiful universe. And we're going to face Him one day. All of us are going to die, and we're going to meet our Maker, literally.
Yeah.
And we're going to stand in front of that Maker, and He's going to ask us, essentially, should you get into heaven? Or we could ask Him, can I get into heaven? Can I spend forever with you in a world that has no pain, no death, no sin, no curse, and so on? And all of us will fail that test. We are all sinners, except those people who've made Christ Lord of their lives. Jesus Christ, God Himself, came down. Jesus is the Creator. He didn't just start His existence in Bethlehem 2,000 years ago.
Right.
He's part of the triune God, and He created the universe, and He came down Himself and paid the price for our sin. For everyone who believes, they can be saved from their sins so that when they die and meet their Maker, they can spend forever in a universe that has no more sin, no more death, no more pain. But we get all that information from the Scripture. The Bible is true. And one of those little clues that indicate that the Bible is true is its consistency. It's a faith position, right? We're not trying to science our way into this. It's a faith position. We believe the Bible's true. When we do that, the observations from the scientific world match it. I love being a Christian.
Yeah. Well, and I know if people want to learn more about just the operations of the universe and cosmology and where Earth fits into it, I know we are offering a free stream of the video that you have right there.
Yes. Yeah. Spike says special Earth and special universe. He's talking specifically about Earth here. But there's these Goldilocks and the Three Bears. There's these Goldilocks zones that Spike talks about in this video here, where the whole universe is fine-tuned in these very narrow windows of all these different laws and things that govern the operation of life and the earth and our distance from the sun and all these different factors that make life possible here. If those factors were off just a little bit, life wouldn't exist. We wouldn't be here. So yeah, for folks who enjoyed our discussions of Pluto here, they'll find this very interesting.
And we'll have a link to that free stream in the description. Richard, thank you so much.
You're welcome. This was fun.